Okay, in this video we're going to have a look at simplifying algebraic expressions by collecting like terms. Now to do that we've got to understand what like terms means. So there's our definition. We've got a few keywords in there that we need to understand as well. So in algebraic expressions, like terms are terms that contain the same variables raised to the same power. Only the coefficients of like terms are different. So first of all, what does variables mean? A variable is something that can change. So in algebra, that's represented by a letter. So for example, in the term 3a, a is our variable. A stands for the number that we don't know. So 3a and 2a could be put together because they both contain the same variable. They've got the same letter in them. However, we couldn't combine 3a and 2x because here the variables are different. A and x stand for different, well, they may stand for different numbers. They are different variables. What about powers? Well, powers are those little numbers that you write at the top, which tell you, for example, that a squared is a times a. Now, we can't collect something like, we can't put a squared with 2a because the powers are different. So here we've got a squared, here we've got a essentially to the power of 1, just one of it. So we can't put these two things together, those can't be simplified. But we could simplify a squared and 2a squared. We could collect these together because we've got the same variable, a to the same power there. Only the coefficients are different. Now the coefficients are just the numbers in front of the variable. So for example, in the ones that we've looked at so far, number in front of the variable, ones we've looked at so far, 3 is the coefficient of a here, 2 is our coefficient of a there, and we can see that those coefficients are different, but we could collect these together. So we'll have a look now what that means. Well, we'll start with 3a plus 2a because it's a nice easy example. So 3a plus 2a, well, we've got 3 of them there, 2 of them there, so altogether we're going to have 5 a's altogether. And if you want to know why this is, well, think about what 3a means. 3a means a plus a plus a. 2a means a plus a. So altogether we've got 1, 2, 3, 4, 5 a's altogether. So there we go. Similar one, then we'll have a look at something like this. Okay, so we've got 3a plus 3a minus a, and what we've got to remember there is that that's 1a, but we don't write the 1 in. So 3a plus 3a gives us 6a, take away 1a again, gives us 5a, and if you were to write that out in full, well, you've got a plus a plus a from 3a, you've got a plus a plus a from the other 3a, and then you're taking away 1a at the end. So if you're going to count them up, 1, 2, 3, 4, 5, 6, take away 1 gives you 5. What about something like this? 3a plus 2b minus 2a. Now this is where we've got to start being careful because we've got two different variables here. So the variables that we've got a and a there, and then we've also got a b there. So remember, we can only collect like terms, so we can only collect the terms that have got the same variables in them. So we can only collect together the a's here. So we've got 3a minus 2a, gives us 1a on its own, and then we've got plus 2b. We can't put this plus 2b with anything else because there's no other b's in the expression, so that leaves us with a plus 2b, and that would be that expression simplified as far as possible. We can't take it any further because a and b are different variables, so we can't collect them together. Let's have a look at another one like that then. If we had something like 4x plus 3y, take away 2x plus y. Let's have a look at what variables we've got here. We've got x and x there, and then we've got y and y there. So collecting together the variables that are the same, we've got 4x, take away 2x, so So that's 2x. We've then got 3y, add another y, which gives us plus 4y. So that's our simplest case there of collecting like terms and simplifying expressions. And you can see this is much more simple to use than this. This just looks really messy. This is much tidier. So if we're going to go on to use these algebraic expressions in later bits in the question, we much prefer having this version because it just looks nicer. There's less clutter. Let's have a look now at some more tricky examples. What about if you're asked to deal with something like x squared plus x plus 3x squared? And this is where we're going to be interested in the powers bit, because although our variable's the same all the way through there, we've got x, x and x, the powers aren't the same. So we can't just start randomly collecting stuff together. We can't say we've got 1, 2, 3, 4. We can't say we've got 5x squared there. So again, identify your different variables to the same power. So we've got an x squared there and an x squared there. So x squared plus 3x squared is going to be 4x squared. We've got one little x on its own, nothing else to combine that with, so it's 4x squared plus x. We can't do anything else with this because these variables are not raised to the same power. Let's have a look at another one like that. What about something like x squared plus y squared plus 3xy plus 2x squared plus y squared. So that looks like really complicated algebra there, but we can just apply the same approach. So let's have a look at what we've got. We've got some x squareds. So we've got x squared, 2x squared, so that's 3x squared altogether. We've got some y squared. We've got y squared and y squared there. So y squared plus y squared is 2y squared. We've also got this random 3xy in the middle. Now we can't collect that with anything else because this is different to this and it's different to this. Okay, this has got x squared in it, this has got y squared in it, this is 3xy, it's different variables. So that just has to stay on its own. So that still looks a little messy, but that's the best that we can do. We can't collect these or make this any more simple because we've got an x squared, y squared and xy there. They are all different variables, so we can't collect them together.